Hello everyone, welcome back to Everything Swift. Today we'll be tackling Leetcode question 240 titled Search a 2D Matrix Part 2. So I've not done the part 1 of this question yet, and the reason is because I think this part 2 is much easier to understand than the part 1, so I'm just gonna do this first, but I will do the part 1 as well in later videos. But yeah, so let's just kind of like take a look what we have to do today. We're given a matrix of a 2D integer array, and we are also given this target parameter here of type int. Basically, what we are tasked to do today is to find out if this target exists inside this matrix 2D array, right? So the key thing to note here is integers in each row are sorted in ascending from left to right, and integers in each column are also sorted from ascending from top to bottom. So this pointer here is extremely important for us to understand to how to solve this question, right? So let's take a look at this example here. We are given this 2D matrix in this matrix parameter here represented in these values, and the target is 5, right? And we can see here the output is true because 5 exists in this matrix, right? So the brute force solution for this, the most straightforward solution for this is just look through the entire 2D array, right? We just go through each number and we just check if the number exists in the matrix, right? That is a potential solution. The only problem for that is it is not scalable in the sense that if this matrix grow in size, right? If we keep making this matrix bigger and bigger and bigger, our time to search for a particular value in the matrix will definitely increase with the size of the matrix, right? Because we have to keep finding throughout the entire matrix. So we have a better solution for this, right? And the tip here and the strategy or the hint here is given in this description here, right? So whenever we see the word sorted, the first thing that we have to come to mind is can we apply some sort of a binary search technique to solve our problem, right? And in this solution, we are not going to directly apply binary search to solve it, but there is a pattern that we can see from binary search to be used in this question to solve this, right? And the portion of it is more of a divide and conquer technique, right? So how we're going to use that here is we're going to check if the target value, uh, while we are iterating through the matrix, we're going to check if that current value is it smaller or bigger than the target value, right? If the value is smaller, we know that it can never be in a particular row, right? And and if the value is bigger, for example, right, is if the value is say is 16, right, we know for sure it cannot be in a particular column, right? So we can collapse the column, and likewise if it's not in a particular row or possibility of it becoming in a row, we can also collapse that as well, right? So I know it's a bit hard to imagine. So as always, let's jump straight into the code, and then probably that will clarify what I was trying to explain. If matrix is empty, I'm just going to check this. I'm just going to return false because if the matrix is empty, there's no way target can exist in the matrix, right? And as always, we are going to increment the rows and decrement the columns, right, in our divide and conquer technique. So rows equals to 0, columns equals to matrix of 0, count minus 1. So minus 1 is because we are dealing with index space bounds, so that's why we do minus 1. And we obviously need to loop through the entire matrix, so let's go ahead and do that. As I mentioned in this divide and conquer technique, the rows are going to be incremented and the columns are going to be collapsed or decremented, right? So rows, if it's less than matrix.count, and columns is greater than equals to 0, right? So we'll keep this while loop alive if those two conditions are met. Then we're going to take the current value, right? The current value is just basically the index of rows and columns in this particular matrix right now, and obviously we're just going to check if the current val equals to the target, right? If it is, that's fantastic. We exit out and just return true because we have found the value, the target, right? If the value is bigger than target, for example, right, and else, right? So if the value is bigger than target, let's say, for example, we are using this example, right? If our target is, for example, 7 or 11 or 15, for example, there's no way that it can number 5 can ever exist in this column because it is sorted in ascending from top to bottom, right? 5 can never be here because 7 after 7 it has to be 8, the next number, or anything bigger than 7, right? So 5 is smaller than 7. There's no way it can be in this particular column, right? So if any point in time the value is bigger than the target, we can know that the column can be collapsed because there's no way the target can exist in this particular column, right? And the same thing as well for rows, right? Is it possible for it to exist in a particular row, right? And the same logic applies with the column as well. If it's not, then obviously we're going to collapse that rows and just eliminate that row basically. And by doing so is incrementing the rows, right? And if we have not found the target in this while loop, which means we have failed, right? We have failed to find it, so we can return false, right? Because if we do find it, it will be caught in this if condition here, right? So yeah, so that's why I was mentioning that if you take a look at this block of chunk of code here, it's very similar to a part of binary search, right? Binary search is more of like taking the middle and then breaking down further, right? Taking the middle, and then we just collapse our sample size, and then we find the particular target, right? Whereas in this case, we do not do the divide by 2. What we do is more of like just divide and conquer in the sense of like collapsing the columns and incrementing the rows, basically. So yeah, let me just run the code and hopefully we got it right. There we have it. So let's try and submit this, and there we have the answer here. It's correct. So yeah, that is how we solve this question using divide and conquer. A little bit glimpse of a binary search pattern involved here, but yeah, I think the greatest hint is given in this description here. So that's why it led me to thinking of how I can use some form of binary search in this question, right? So yeah, that's it for this video. I hope you guys find this kind of videos helpful. If you do, please feel free to subscribe to the channel. I'm trying to grow this channel as well. Please feel free to share it with anyone who might be interested in this channel as well. So as always, thank you very much for your time, and take care, and bye bye.